Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to another NL Mathman Math Help stream. Today is day 36. Day 36 of my, well, I mean, stream 36. Way more than day 36 of distance teaching. Way more. This is week 8 we're in right now. You know? I mean, yeah, we've been at this one for a while. Good afternoon, Mathman. Yes, real Albert Einstein. Good afternoon to you, too. Got a little bit of a guessing game here. You can tell me another one. If you can tell me what city I have in the background here, maybe I can get you another few bonus marks. This one's gonna be tough though. Like, how in the world? What do you do? I guess you can do a reverse image search somehow. Like, take a screenshot of me and then image search it and see what community comes up. Right? It's gonna be a tricky one. Um, but we're taking a journey. We're taking a virtual journey through scenic Mathland, like it says there, right? Yes, I'm going to start off. I'm going to start off. The reason I decided to start off with a picture of this community specifically is actually because of something that I made only recently and that I was having a snack of before we started here today, right? Before my, like I said, this is my break, right? This this like 7-8 minutes of rambling. This is my daily break. Yes, good day, Esther, as well. I'd like to show you guys something here. I've taken one bite out of it already, so it's not quite so pristine, but believe me when I tell you that they're very shapely and picturesque, very yeah, very photogenic and picture perfect little things that I made. Look, there it is. There it is. Look at that. What is that? Look at all that wonderful sort of ridges and crackling on there. Look how smooth it is, and look the bottom is nicely baked. Look at that. You know what that is? I mean, it was very circular. But this is a ginger snap. This is a homemade. I made these myself. I've made ginger snaps. I mean, dozens of times, maybe even 100 times, maybe even hundreds, probably dozens though. Right? And I make them with one of the recipes off of Crosby's website, the molasses site. Right? Um, and yeah, to get those ridges on the top, that's the secret. You got to roll it in normal white sugar, not powdered sugar, because it doesn't get the right texture, and not brown sugar because it's too moist. After you make the little dough balls, you got to roll them in white sugar, and then when it bakes, they sort of flatten out a bit, and on top you get this really nice sort of crackling look on there. But the reason I thought about this community that I have in my background specifically is because that's a cultural trait that we share with from Newfoundland with this thus unnamed, so far unnamed country is that ginger snaps are a popular part of the cuisine, of the traditional cuisine, right? Although the ginger snaps in this country behind me are much thinner. They tend to be very thin, and also they tend to. There's a tradition to have blue cheese. You smear a soft blue cheese on your ginger snap, which is delicious, by the way. London? No, no, that is not London. Although great guess, yes, you could say that might be the River Thames, but no, no, that's not London behind me. Look, there's ice. You see, well, maybe it's hard to pick out there, but there's ice in the water. Let me tell you, the Thames never freezes, right? Like if London gets like half a centimeter of snow, the place just shuts down. All the, I mean, to be fair, right? It's a big city and there's no plows and like the trains can't operate with snow down, right? So there's reasons why. There's reasons why like England shuts down when there's snow, but there's very rarely snow. How's about I'll show you another shot of the city. Here's something else we share. Here's something else we share. Look at that. Doesn't that look doesn't that look very, very St. Johnsy? I mean, it's a little bit bigger, right? And there's no water there immediately in front of us. But look at that. That's very Jelly Bean Row like, isn't it? Yeah. They're a bit large. They're a bit large for row houses, but they're mashed together and they're rectangular and they're all these bright colors, right? But yeah, ginger snaps and row houses and snow, right? Where do we think that might be? Scandinavian, yes, yes, indeed, it is. It is Scandinavian. It's good. Okay, that's worth a few points at very least, right? Like to know. Maybe you Googled ginger snaps with blue cheese and you found that it was Scandinavian, which it is. It is Scandinavian. Yeah, that's close enough. I mean, I'm not gonna. You could just start guessing Scandinavian major cities at this point. Oslo, no. Helsinki, no. Stockholm. It is Stockholm. It's Stockholm in Sweden. In Sweden, the Swedish chef. Remember one of my favorite like traveling food stories. I've got a bunch of them, bunch of because I always try to find like interesting and different food when I go places, and um, I got a few funny ones from different spots. Um, but one in Sweden that was really nice was I was in this small little restaurant, and there was a menu right written on the wall, and most stuff in Stockholm is in English because you know a lot of Scandinavians and Swedes especially speak probably better English than a lot of native English speakers, right? Because they're taught in school from a young age. It's a super easy place in the world to go if you're a monolingual English speaker like myself. Like I said before, I have the French of a Canadian eighth grader, right? So not really. It's okay. Like I could ask where the washroom is, but that's about it. But yeah, so there was a menu, like a normal menu, like in the background or whatever, and that was in English and Swedish. But then there was this like piece of paper just taped, like with masking tape, taped to the cash register with like a special written on it that was just written in Swedish, like a daily special or whatever. And I was like, I want that. Well, it's that, that thing right there. That's on the back of the cash register. And this was like at like 10 in the morning, I guess. So I don't know if it was the proper time of the day to have this, but what they brought out was like this chowder like stew of like onions and carrots and potatoes and stuff. And then there were these like dumplings in there that were like doughboys. Like for the world, they were like doughboys, but inside they were stuffed with crab and salmon, I think. Crab and salmon and maybe some sort of white fish. I can't remember. Maybe it wasn't salmon. I don't know. I can't remember what fish it was, and I didn't take pictures of it because I don't take pictures of food all that often. But it was really good. It was like a cream chowder with these seafood stuffed doughboys, basically. I have no idea what it was called or how I would ever order that in a restaurant again, but it was delicious. And it was an odd breakfast though. But that's, adventures in buying random foods from restaurants where I don't know to speak the language, right? I've done that in Czech Republic. I did it in Greece. Did it in uh, Slovakia. Vienna. Although that's to be fair, like I speak enough German to know that I was getting deer and rice when I ordered it in Vienna. That's about it though. Anyway, yeah, I could ramble about the various foods that I've had while going places for a long time. Of course, going places is not the kind of thing that we're able to do right now. So now we have to settle for virtual journeys. And today's virtual journey, when we're about done with the Swedish leg of our virtual journey, we're going to head off to Mathland now next. So today, I'm going to get to converting units of measurement first. We're going to do a little bit on that. I know it seems like I do that every day, but it's a big topic. It's in a lot of courses, and I'm going to beat it to death as much as I can. After that, area of irregular 2D shapes. That one comes up relatively commonly as well, right? But we'll see some more on that one. Surface area of regular 3D shapes is on the same course, so all those are Math 1102A. Then properties of angles and sine and cosine laws, that will be for Math 2101A, which is Betty Ann's current course. So that'll be a little bit of the piece she just finished, and then a little bit of the piece that she's working on now. Okay, so converting units of measurement. I wanted to start that one on, let's see. There's a bunch of different activities all out of this one PDF, so there's going to be a fair bit of scrolling involved in today's stream. Apologies in advance for the amount of scrolling that I'm going to be doing. I'm going to try to not to use the mouse wheel as much, right? So you're not subjected to the scroll, 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 scroll noising. Okay, let's go on over here. Oh, any convex hull problems? No, no. Although there were some boats in that last picture. Hey, yeah, yeah, that's a good idea. We could do some physics problems. Yeah, talk about some buoyancy, some displacement, how much water it displaces, and the maximum mass of the boat that you could have to stay up above the water line, right? That's good. That's good stuff. I could do that. We'll get to that eventually, maybe. I think Troy is working on uh, he's working on physics, right? And it's almost all Newtonian physics, which is to say, F equals ma, and then like I think there's a bit of gravity stuff. The gravity unit's good. Astrophysics is actually surprisingly easy, and because it's an actual system where there's not as many variables, right? Anyway, this is now Math 1102A, and this is it's part from assignment 3. We've Evan did this one recently, and Renetta did it most recently. So these will be some decent ones for them to take a look at. I'm not necessarily going to go down through all of these questions, but I am going to do a scattered few off of here. So let's see. Number 5, 45 kilometers is some number of miles. Oh, yes, yes. Before I get to this, now I've had a really, really hectic morning today, so I don't have quite all my PDFs open right now. But let me just go and grab that. Here we go. So this is the conversion sheet that we're going to be using here. Just zoom on in. So now we're looking at miles and kilometers. So we're going to need this one. See that one there? 1 mile equals 1.6 kilometers. So I'm just going to copy that down here. 1 mi equals 1.6 km, right? Now, another annoying thing that we had to deal with here because we're dealing with imperial to metric conversions is that we had to notice that mi and m are totally different units, but you might be converting one to the other, right? Because m is meter, which is a measure of length or distance, and mi is miles, which is a measure of length or distance, right? But one's imperial and massive, and one's metric and smaller. Not that miles are massive, but you know, in human terms, a mile is fairly long. Anyway, so we're going to go 45 kilometers to some number of miles, right? So I'm going to show you the cross multiply method here now. Like I keep saying a bunch of times, you know, it's kind of a misnomer to even call them different methods at all, right? Because it's kind of just the same thing. No matter if we do, you know, cross multiplier, if we do unit canceling. But I'm just going to show you how to do it for these ones, right? Because we know that there's 1 mile per 1.6 kilometers. And I know. You know, I'm trained, well, trained in a few different subject areas because I am trained in math. You know, I did do an undergrad with math. But, you know, as I guess my brain works very language oriented, like very Englishy, and you know, grammar wise is kind of how my mind works. And I find that it's very intuitive to think of a question like this as meaning per, because that's literally how we read it. We would read 1 mile per 1.6 kilometers. And even just saying that phrase aloud kind of makes sense, right? Because that's just what the conversion is. There's 1 mile per every 1.6 kilometers. So, but then we're saying, well, there's some unknown number of miles, which we don't know yet, per every 45 kilometers, right? And then from here, we can do our cross multiplying, which as we recall, right, is once we've got a over b equals x over y, that becomes ay equals bx, right? And I'll just put that here in an aside over there, right? So we're going to do the same sort of deal over here when we cross multiply. We're going to have 1 times 45 on the left-hand side, because this one's going to come up, and then we're going to have 1.6 times x on the right-hand side. Now, I know that this is kind of has an extra step because of this last bit, but again, I want to keep showing this because this is the kind of algebra that you're going to see again and again and again and again. So we're going to do 45 over 1.6 equals x, and then we're going to have 28, I'll call that 28.1. 28.1 equals x. So we know that 45 kilometers is 28.1 miles, right? I'm going to do another few of these ones. Let's see, before I get on to ones that have a bit of a twist to them. Let's do number 7. Let's do number 7 with unit canceling method. Okay. Now, the unit canceling method sometimes is a bit more intuitive for students, and I do think it's really useful because you're seeing how units factor into algebra the same as any other part of the equation, right? You can stick units in there. All right, so here, for example, say we had 60 kilometers, so we start off by writing that one down. Then we know our conversion factor is the same as over here. Esther, you're working on your assignment? Okay, yep. Let me know if you have any questions about that one. I do, as you saw on the intro screen, I have a lot to get to today. But if you want me to cover something for your assignment, I'll either get to that on stream today, or I'll definitely make time to get to it tomorrow if we go a bit long. Am I doing anything for you? Well, no, not today. You didn't ask for anyone's, and you seem to be doing okay with the online calculator, I guess. I gave you some intro to that, and you haven't asked any questions about it, right? So I assume you're doing okay with those. Let me know if you have any concerns or anything like that. But otherwise, no, I won't be specifically dealing with that assignment today, not unless you ask. Right. So for here to carry on with the unit canceling. Yeah, no problem so far. Okay, great. Yeah, good. Good. Let me know if you have anything. I mean, you know how it works here, right? I mean, you've been going in this program for a little while, so you know how we do it. Right? So 60 kilometers. Now our conversion factor is the same as over here. There's 1 mile per every 1.6 kilometers, right? The same as this one. But do I put the kilometers on top or the kilometers on bottom? Well, because this is unit canceling method, just that name sort of gives it away, right? We need to cancel the units. So if there's kilometers on top here, we know that kilometers are going to have to be on bottom over here. So we're going to have 1 mile per 1.6 kilometers, right? We know kilometers are on bottom because we have to have kilometers cancel with kilometers like so. Then we end up with 60 over 1.6 is the number of miles. And then 60 over 1.6, well, break out my old calculatrice. That's French, isn't it, boy? Calculatrice. Got that name for the French, didn't we, boy? Boulevard. Anyway, I don't need to randomly go into a buddy what's his name bit, but I could. Just letting you know that I could. Okay, so that's all there is to that one. Let me see. I wanted to do number. Yeah, let's do number 9 as well, just to show a different type of unit here, and then I'll quickly move on to some other types of questions. So now in number 9, you see we're doing miles to yards, right? That's different than if it was m to yard. Then I think that's I can't recall now because I've done so much correcting today, but I think the issue with the student might have been taking mi to mean meters here instead of yards, right? But of course mi is miles and not yards. So what we're going to need to do is switch on over to here, and now we're going to need thankfully we give you this guy, right? 1 mile is equal to 1760 yards. Now in the States you would probably be expected to memorize that guy, right? But here I'm never going to expect you to memorize that one because that's just a factoid that your brain doesn't need to make space for. Anyway, no, it's a good thing to memorize for sure. It's possible that you'll be working in like aviation or some industry that uses imperial because that's where most of the vehicles are made. I don't know. Knots are different anyway, or is it even knots that aircraft speed is measured in? I don't know. I'll have to ask Dad next time I'm talking to him. Anyway, so we've got 0.9 miles is equal to some blank number of yards. Well, say I was to do unit canceling. Again, just to make this a little quicker, go ahead and do that one. Well, I've got 0.9 miles, and now I want to cancel miles, so I know miles are going to have to be on bottom, right? So it's 1 mile per every 1760 yards, or it's 1760 yards per 1 mile, right? Because just to be very, very clear about what it is we're doing, when you have a conversion factor like this, as long as your units are still there, you can write it either way, and it makes sense, right? Because there's 1760 yards per 1 mile. That's true. Or there's 1 mile per 1760 yards. So I could write it the other way around as well. As long as I keep my units in there, I can write it in either direction that I want. And I do that in order to cancel out and get 1 unit in the end. Because if it was the other way around, I'd end up with, miles squared per yard, which is a meaningless unit. It doesn't make any sense whatsoever. But here now, my miles are going to cancel with miles, and I'm going to have, I need to scroll over a touch. I'm going to need 1760 times 0.9 gives us 1584. Right? So the only real tricky thing about that guy is, in my opinion anyway, noticing that it's MI and not M. right? Because 0.9 empty yards, well, that'd be a super common one to see, right? That's almost one. It's about 1 yard for zero point 0.9 meters, just shy of one. But anyway, that's not what the question was, right? Now I wanted to do 19 and 20. There we go. Oh, we're still on the we're still on the sunset. Look at that. That's a nice new background, isn't it? That's good. I brought that one up yesterday so I would stop sneezing. It seemed to work. Or stop hiccuping, I think it was. 19 and 20 I want to do. 19 and 20. Okay. Gonna zoom out a touch. Oh, okay. Well, I mean, here's a reason. I guess here's a reason for why we might need to know this stuff. The speed limit in many American towns is 30 miles per hour. Canadian takes a trip to the U.S. and is driving at 90 kilometers an hour. Determine, however, how many miles per hour the car is traveling over the speed limit. Like, it's a friggin' lot. Oh my God. Doing 90 in a zone that's 30 miles per hour. I mean, I know a mile per hour is faster than kilometers, but it's not that much faster, buddy boy. Somebody's going to get a whopper of a ticket. So I guess, practically speaking, this is why Canadians need to be aware of this conversion, right? Because you drive to the States and then you just get skewered on a speeding ticket. But I mean, most speedometers, real talk, right? Most speedometers show miles per hour and kilometers per hour. So really, it's like you can't even blame the math at that point. Anyway, what we had to do for this one is convert one of the two to be the same unit, right? Want to become famous? No, absolutely not. There you go. Um, go, I'd say about 55 miles per hour. 55? Yeah, 55 is pretty close to right, isn't it? Because the shorthand is to know that 100 kilometers is about 60, right? That's just sort of the shorthand to remember in your head because those are common highway speeds. But you're right, Albert Einstein. It's going to be about right for that one. But here now, even though it's miles per hour and kilometers per hour, we don't need to concern ourselves with the per hour. Now, Albert Einstein, it's good for you to be the one that showed up in chat here, or one of the ones, because in your courses, you're going to be dealing with a different type of speed conversion. You're going to be doing kilometers per hour to meters per second, right? And because the unit of time changes there, the conversion is a bit different. It's not just the same as kilometers to meters. In this one, where it's miles per hour and kilometers per hour, we can sort of ignore the per hour part because the bottom unit or the hours is the same in both cases, right? Well, what we're going to do is this 1 mile equals 1.6 kilometers, so the same conversion factor as we had over here, right? So I'm just going to go ahead and say 30 miles times 1.6 kilometers per 1 mile. It's going to equal, I'll go below because I'm running out of space over here on the side, cramming it all together. That's just going to be 30 times 1.6, which I should be able to do in my head because it's, 30 plus 18. But, so that is 48 kilometers per hour. Okay? Determine how many miles per hour the car is traveling over the speed limit. Oh, it's asking for miles per hour over. All right, cool. Well, I just made us do a little more work, but that's fine. I'm the teacher. The teacher always makes you do work. That's what I exist to do. Right? So I'm going to do 90 km per hour minus 48 km per hour equals pretty clearly 42. So now we had to figure out how many miles per hour that represents, right? So I'm just going to go back and use my same old conversion factor as before. I'll do it over here. 42 kilometers times 1 mile per 1.6 kilometers. And then that's going to cancel there and cancel there. We're going to have 42 over 1.6. Going to give us 26, I'll call that 26.3. Although in a physics course you wouldn't. You would call that 26.2. But anyway, we're not getting too cross-curricular here today. That is about 26 miles per hour over the speed limit. And since this is a word problem, I'm going to model how we would actually answer these questions. So we would say, 26 mph over the speed limit. Right? So that person is going to get, like I said, they're going to get one whopper of a ticket when it comes to it. Okay, I want to do question 20 as well. Then I'm going to move on from this assignment into another one. I do have quite a few ones to get to today, like I mentioned. I know that I end up talking faster too sometimes when I've got a bunch to get through. But I naturally talk pretty fast, right? Because I'm from Newfoundland. That's what we do. That's part of our identity, man. This is just rambling on quickly. So my radio voice is consciously, my radio cadence, I should say, is consciously slower than my speaking voice. Although sometimes I regress back into my speaking voice. I have done quite a bit of public speaking and talking in front of people, and you've always got to consciously sort of talk more slowly than you would normally, or sometimes it doesn't come off very clearly. Although streaming is a bit different, right? Streaming is meant to be more conversational, and perhaps a bit more natural sounding, more like I don't know, more like radio than it is like a speech, I guess. Lori is looking at knitting patterns on an American website. Pattern for a sweater calls for 115 yards of wool. Calculate the number of meters of wool needed. Okay, so now we got to go back to our conversion chart, right? So now we're talking about yards and meters. So now we got this guy down here. So we've got our 1 yard equals 0.9 meters. Right? So it's got 115 yards. How many meters is that? Well, there's, again, right, there's two different ways that we could do this one. So I'll show the cross multiply method here because I've done this a few times. The other way. Cross multiply method is going to be 1 yard per 0.9 meters. And that's going to equal, 115 yards per some unknown number of meters. So then once we cross multiply, we'll have a 1 times an x on the left, right? It's a bit blurry down in the corner there, isn't it? And then we're going to have a 0.9 times 115 here on the right. So then x is going to equal 0.9 times 115, which is going to be 115 minus 11.5. But anyway, 115 times 0.9, 103.5. Right? And then just to show, just for sake of beating it to death, I'll show the unit canceling. And again, right, you don't need to do any of these twice, but I'm just going to show two different ways, the two different ways that I like to show how to do these ones. 115 yard, and now we got to make sure our yards are on bottom, right? So it's 1 yard per 0.9 meters, or 0.9 meters per 1 yard. Either way it works out. Yards canceled with yards. We have 115 times 0.9, which is 103.5 meters. All right, sorted. Nothing to it. All right. That was the first thing that I wanted to get to in that course down, so we'll cross that one off. Yes. Next topic. Jump back over to my intro page here. So that was converting units of measurement. Ah, yes, area of irregular 2D shapes. Good. That's a good topic. Okay. So I'm going to introduce you to a bunch of scrolling noises as I scroll on down to worksheet 3.1. Shrink. Okay, so worksheet 3.1 then. There was a few that I had slated to do that I'm not actually going to get to. But there's yeah, here we go. Okay, but that one's a bit trickier to start off with. Strangely enough, question 15 is like an easier version of question 12. I don't know why in the world it does that. Oh, I should have removed that word, shouldn't I? Anyway, back over to my document display. Here we go. I'm going to do question 15 here next. So find the area of each figure. Zoom in. So let me, yeah, go back to the snowiness. There we go. I'm a bit off-center today too, aren't I? There we go. Nice. Nice. Okay, so we're going to find the area of this shape over here. Actually, after all that work adjusting that scene, I'm going to use this scene instead. That's a bit better. So this now is Math 1102A, and this is worksheet 3.1. I'm going to do question 15 before question 12, because question 15 is an easier version of question 12, oddly enough. I want to eat the rest of that ginger snap. It's like sitting there taunting me with its nice, ginger and cloves and cinnamon and real butter, always real butter. And molasses, always molasses too. I love molasses. It's just taunting me with its deliciousness. Okay, it's not quite fully accurate, but whatever. It all works. Get there in the end. That's the important part. 3 feet, 6 feet. Okay, so now this one's asking for compound area. And there's two different ways to do compound area. Basically, we can either cut the shape into two pieces, or we can sort of treat it as like a full rectangle and then subtract the missing bit. Both are super valid because sometimes one's easier than the other, and it's important to be able to know how to use the two of them. Always real butter. That's right. That's right, Betty Ann. Yes. Hey, Slayer Darth. Yeah, welcome back. I'm going to first. I'll do the cutting into two. Real butter and molasses on hot homemade bread. Ooh, boy. Boy, that sounds good. That does. That sounds amazing. Homemade bread right out of the oven. Oh boy. Yeah. That's what it's about. So I'm going to cut it down here, sort of like slice the shape down through this way, right? Then what we're going to have to do is figure out the dimensions of these two rectangles. We got this small one and this big one. Now the main way that people make mistakes in ones like this is by counting parts of the shape twice, right? Like if I said this bottom shape was 2 by 9, well that's not this shape. That would be if it went across here. It would be 2 this way and 9 this way. So that would be this whole chunk, right? But I've done it a bit differently. I've split it down this way. If I had split it over here, then strangely enough, it would have been a little easier. Triangles have two pairs of equal lengths. Yes, indeed. Yes, they do. That's right. So it's 2 feet this way. Well, what's this one, right? Because I got to figure out this guy. Well, it's 6 here and it's 9 here, so we know this has to be 3, right? So this one's going to be 2 times 3. This part here is going to be 6 feet squared, right? And now, down through here, we know this one is 3 and this one is 2. So this whole side, the whole side down here has got to be 5 feet. So this one's going to be 6 this way and 5 this way, which makes 30 feet squared. So then the total is going to be 6 plus 30 equals 36 feet squared, right? Not super difficult. So now I'm going to do the subtracting method. I'll do this one in red just to show you. Because when we look at this shape here, right, we could see it like a backwards L, or like a really fat version of a Tetris block. Tetris blocks aren't quite shaped like this, right? They're a little bit more L-shaped. But we could see this as a full one big rectangle that's had a piece subtracted, right? And we could see the subtracted bit as this red bit out here, right? So if we were to look at this as a full shape, like a full rectangle that I've now drawn out here, so the area of the full shape is going to be, well, it's 9 feet across the bottom, and it's 5 feet up here as we already found, which is going to be 9 times 5 equals 45 feet squared. And now this one over here, the one that's done in red, we know it's 3 feet across the bottom, 3 feet up this side. So area of the missing, or the subtracted bit, is going to be 3 times 3 equals 9 feet squared. Work out the area of the missing and subtract it from the total. That's right. Yeah, exactly. And then we're going to do the area, I'll just call this area total, is going to be 45 minus 9, which of course equals 36 feet squared. The same thing because we did it right the first time, so we're going to get the right answer, right? Now this one, this example that I just walked through is a fairly easy example because of just the shape of it, right? Sometimes you're going to get ones like later on when you see this subject again, where one of these two methods is way easier than the other. So it's important to know that both of these work, right? Because sometimes you'll kind of be forced into doing one or doing the other. But for this case, we can go ahead and solve it, a few different ways. And that's the same for 15b over here, right? I'm going to do 15b, and then I'm going to do number 12. Then I'm going to move on to the next topic, I think. This one here is the same sort of shape, although I'm going to have to zoom out a touch. There we go. The aspect ratios of my various windows here are a little odd, so sometimes I can't get it to be as efficient as I would like. Draw this over here. It's up here. It's across. It's down. This over here. There we go. Okay. Let's see. We've got 4, 6, 3, 10, and this is a right angle. We don't actually totally need to know that was a right angle, but it's good. It's good to, well, we kind of do. I guess we kind of do, yeah. Okay, so I'll call this the cutting method. Right? I'll do this one in black just like I drew it up there. This time I'll cut it, instead of vertically, I'll cut it, actually no, I'll cut it vertically again. Why not? Chop, chop, chop. There it is. I'm just going to circular saw and just go right over it there. What are we going to have for this one? Well, this one's going to be 4 times 6. So I'll call this area 2, and I'll call this area 1, right? Just because I go read from left to right. But I'll do area 2 first because I'm weird like that. It's going to be 4 times 6, which is 24 centimeters squared. We can see that one fairly easily, right? 4 across the top, 6 down the side. Easy peasy. Area 1, well, we can see it's 3 in one dimension. But then is it going to be 10 in the other dimension? Well, if we took 10 in the other dimension, the problem there is that it would be 3 by 10, which would be this full shape. So we'd end up counting this bit down here would end up actually being counted twice, and we don't want it counted twice, right? If we count it twice, we're obviously going to get the wrong answer. So we have to find out what's this length from here over to here. And we know if this full thing is 10, and this bit is 4, then this has to be 6. So it's going to be 3 times 6, which is 18 centimeters squared. Even though in the diagram here and on the diagram over here, it looks like this chunk is way larger than this chunk. It kind of does look like that. It doesn't mean jack squat, right? Because like I've told you 100 times, if I've told you once, teachers are sneaky, right? We like to pull sneakies on you, and sometimes the diagram is not going to look anything at all like what the numbers on it represent. Usually it'll be in the vague ballpark, but don't try to eyeball stuff based on how the diagram looks. Go with the numbers that they've written there. So now the area total is going to be, of course, area 1 plus area 2, which is going to be 24 plus 18, which is going to be 42 square centimeters. Right? Or I could do a subtracting method. Actually, I won't belabor the subtracting method one now. I'm going to move on to the next one. We are going to see a subtracting method question shortly, right? So we will get back to that sort of topic. I'm going to go up and do question 12, which as we see up here, here's question 12. Question 12 is a little bit more complicated, so I don't know why they gave you that one before, doing the easier ones, but whatever, right? This is math. This is math. This is math 1102A still, and this is worksheet 3.1 still. So Renetta, if you're watching, this is really good for you because this is the topic that you're just about to do. So I'm sort of giving you some answers. Um, you know, it's the benefits of watching the stream, I suppose. So I'm going to go ahead and draw this one out. Oh, crud! Sort of caught my sheet in my ruler there. I have drawn this shape fairly inaccurately compared to what the diagram is in the example, but you know, never you mind. Don't worry about a thing. Every little thing is going to be all right. Since the bottom is 62 centimeters, you know the bottom length of the rectangle is 34. Yeah. Okay, so we've got a 34 cm here. And then from this side on over to this side, the full side, this one is 62 cm, right? All the way on across. So the bottom length of the first triangle is 10. Yeah, good. We do need to find that. That's right. 26 centimeters high. Okay, so we're really only missing one measurement here, right? But what we've got is we've got our, I'll call this A1, A2, and A3, right? And we know that A total is going to be A1 plus A2 plus A3, clearly, right? Not super hard. The full area is all of them added together. A2 is super easy, so I'm going to do these ones first, right? A2 is the rectangle here. So we see that that one is 34 by 26, like so, is 34 times 26. And the right triangles, yes, exactly. We could use Pythagoras if we wanted to. Yeah, if you were told to find the perimeter, you're absolutely right. You have enough information here to find the perimeter because you're told these are right triangles, which means you can use Pythagoras to find this length and this length. That's true, right? But I believe in this assignment, yes, this question doesn't actually ask for perimeter, but you're absolutely right, Slayer Darth. Yeah, you could on a test, say for the unit, you could absolutely see this exact same question asking you for perimeter and area. It's true. So that's going to be 34 times 26 is 884 centimeters squared. Now, how are we going to do A1? Well, just like Slayer Darth was helping us with there in chat, we know that this full side is 62, and this part here has got to be 34, just like the one up here, and this one here is 18. So if we're going to find this, the base of A1 is going to be 62 minus 34 and minus 18, which gives us 10. So we know this one here is going to be 10 cm. So now I know that A1, well, area 1 is a triangle, right? So it's going to be half base times height. And because these are right triangles, we know that this is the base and this is the height, right? Because the base and the height of a triangle have to be perpendicular to one another. So they have to be offset at 90 degrees. So then A1 is going to be a half times 5 times 26. Sorry, a half times 10 times 26. I'm getting ahead of myself, right? So that is going to be 5 times 26, or 130. 130 square centimeters, right? Let's carry on over here. I'll just write it over here. A3 is again going to be a half base times height because it's a triangle. A3 is going to be a half times 18 times 26, which is going to be 9 times 26, which is 260 minus 26, which is 240 minus 6, which is 234. Just going to see if my mental math is correct. No, I don't need natural log right there. Thanks, calculator. 234. Yeah. 234 centimeters squared. So then area total is just going to be 884 plus 130 plus 234. So the area total is going to equal 1248. 1248 square centimeters. Right? Good stuff. Good stuff. Okay, so I know maths is fun. Exactly. Math is fun. I actually linked a student to a page on Math is Fun there today. Have you ever that exact website, Math is Fun is what it's called, is a really good that's a really good intro. Like it's always written at an accessible level. So like any student can really approach it, but it actually is goes into some decent detail. Like the one about circles, it starts talking about secants and tangents and stuff like that, right? Which is the type of topic that you're not going to necessarily see right away when you go get into circles, but it does handle it in some reasonable detail. Yeah, Math is Fun is really great for geometry. Yeah, absolutely it is. There is one. I know I said earlier that I was, well, if you're on my mailing list for the class, you know that I mentioned circles, and then I took those off the list after because I wasn't actually going to cover those because I think this we didn't really need to after all. But I am going to cover this circles question just because it's a really good example of a combination of circles and um, compound area like we're talking about here, right? So let me just go over to my document display. And this is some good Canadiana, right? Because this is, or even Newfoundland, right? Because we've actually become like we're like a curling province now, right? Like what with the Team Guju, right? Come on now, Olympic gold medalist curler, because it's a curling example. Exactly. Yes, Alf, that is exactly right. Because it is curling, and I'm from Newfoundland, and we've decided to take pride in curling in the past few years, thanks to Brad Gushue and the gold medal. Nothing beats the Norwegian pants. I don't I don't know off the top of my head what you're referring to, but let's you'll find out. Google Norwegian pants afterwards. Okay. So let's go down through the different ones of these. 7A, well, in curling, the house is a set of different size circles with the same center. So they're concentric circles, we call those. The manager of a curling rink in St. John's needs to know the area of the house. The house has dimensions as shown in the table below. So the white button, outside diameter 1 foot. So calculate the area of the white button in the center of the house. Well, the area of a circle is, of course, pi times radius squared, right? So here, this one's just going to be pi times 1 squared, or just pi times 1, which is going to be the area is, we'll just round that to 3.14 square feet. Oh, sorry. No, that's the diameter. Ah, my mistake. My mistake. Oh, my goodness. My goodness. Okay. That was the diameter. See? Norwegian curling team had checkered pants in the national colors. Okay, that's pretty good. Yeah, I can see that. That's nice. So it's 0.5 squared, right? Because, of course, its area is pi r squared. And here the diameter is 1. Therefore, radius is 0.5. Yes. Okay. See? That's the thing about being a teacher is you can make a mistake and then you just call it a teachable moment and you're good to go, right? That's what it is. Teacher never makes a mistake. They're just testing to see if the students notice. I'll just call it 0.79 feet squared. So now calculate the area of the house, which is the large circle or the blue ring. Now, one reason that I wanted to do this question here specifically is, like I said, is because of this one, because of question B. Strangely enough, now we're doing a lot of working backwards here, right? Because to get the blue ring, just the blue outside ring, well, what do? Well, the area of, well, if we look over here, right, the blue ring is just this bit on the outside. So how do we find just this outside bit? Well, we do it sort of like we just were doing those last questions, right? We can find the full area of the circle here, and then we subtract the area of this white one inside, right? This one here. And that's how we find the area of just the ring. It's like, say, like a washer or something like that that has a that is just a sort of a ring of metal, we can find its area by taking the area of the outer circle, subtract the area of the inner circle, right? So that's the same thing we're going to do here. So the area of the outer circle is going to be, again, pi times radius squared, right? But it's going to be pi times, well, we're told that the diameter of the outside one is 16, so the radius is going to be 8. My goodness. The rate, no, okay, okay, chat. Okay, chat, don't mind me. We're told that the diameter is 12, so the radius is 6. Boy, oh boy. You know, like I said, right? We get there in the end, and that's the important part. So the area is going to be 36 pi's, which is going to be, again, right, exactly 108. What in the world? That's not exactly 108. 113.1, we'll call that feet squared. Now we're going to need the area of the inner, right? Because we have to subtract. The inner one, we see the diameter is 8, which means the radius is 4. Pi times 4 squared, which is going to be 16 pi. Now, anyone who's used to doing math like this probably wouldn't have converted into a decimal. You would do this one 16 pi, this one 36 pi, and then subtract and get 20 pi. And then find the decimal, or maybe not even find the decimal, it's fine. I'm just going to go ahead and use the decimals though. We'll call that 50.3 feet squared, right? So then the area of the ring is going to be the area of the outer minus the area of the inner, right? Which is going to be 113.1 minus 50.3, and that is going to be 62.8 feet squared. There we go. Right? And then calculate the area of the red ring. Well, again, that's going to be pretty similar to what we just did, but I'll do that one. I'll do that one just to be thorough here for this guy. So C, again, right? It's going to be area of the ring is going to be area of the outer minus the area of the inner. We already have area of the inner. We got that in part A up here, right? So now I'm going to go ahead and do the area of the outer is the arrow. So we're looking for the red ring in the center. So that one's going to be pi times 2 squared, which is going to be 4 pi, which is going to be 4 pi, exactly 12. 12.6, I'll call that. So then we'll have area of the ring is equal to 12.6 minus 0.8. I'll round the above one to 0.8. So then it's going to be 11.8 feet squared. Okay. So that's a few ones that I wanted to go over from 1102A, this worksheet 3.1. Yes, there were a few from worksheet 3.4 that I wanted to go over as well. Right? I said got quite a few to get down through today before I get back to my correcting and so on, and so on, and so on. Yes, so this one, yes, okay, good. Because now we're on to the next topic. Right, so if I go back over to my intro screen, we see we've got converting units of measurement. That one's down. Area of irregular 2D shapes. That one's down. So now we're going to do surface area of regular 3D shapes. Okay. Surface area of regular 3D shapes is on over here. Still Math 1102A, but now it's worksheet 3.4. And I'm going to do questions 9 and 10 here. Let me scroll this guy back up. Yeah, I'll do these in order. So question 9 then. Tennis balls are sold in cylinders with a plastic lid. The diameter of the cylinder is 8.4 centimeters and the height is 26 centimeters. Draw a sketch of the cylinder. Determine the surface area of the cylinder without the lid. Okay, let's do this drawing. And you know, I think that Pringle's original intention was to make tennis balls, man. But then the day that the rubber was supposed to get there, a bunch of potatoes showed up. And Pringles is a laid back company, man, so they said, fuck it, cut them up. It's a Mitch Hedberg joke. I didn't really deliver the cadence. That wasn't a very Hedbergian cadence there. You ever hear Todd Glass's bit about like what if Rodney Dangerfield did Mitch Hedberg jokes? I mean, it's funny to like exactly comedy nerds, but it's a good bit. All Todd Glass bits are good bits, though. I mean, real talk. Right. So the diameter of the cylinder is 8.4 centimeters. So the diameter is going to be across here. There we go. And the height is 26 centimeters down here. Now draw a sketch of the cylinder. Got it. Use it to determine the surface area of the cylinder without the lid. Okay, sure. Well, we know that the surface area of a cylinder is equal to 2 pi r squared plus 2 pi r h. Now, if you were to Google it, you would see it written a little bit differently with this simplified a touch. But the reason I don't show the simplified version is because of questions exactly like this. We need to be able to know what parts of the real shape this formula corresponds to. And this here is the top and bottom, and this is the sides, or the lateral area, right? And I do like to talk a bit about the derivation, like how we get that formula. Like, for example, if we were to take a cylinder, like, say, this, right? Imagine this was a perfect cylinder that I've got here, right? We see that my chroma key is going bonkers. But we see that this cylinder, right, is just a rectangle rolled up, right? Look at that. That's funny stuff. But what's the dimensions of said rectangle? Well, this side, the height, wow. The height of the rectangle, right, is the height of the cylinder. But the other side of the rectangle, this side up here, across the top, that there is the circumference of the circle that's on the end, because it's the distance out around here becomes the distance across the top here, right? Which is why this term. Because we've got 2 pi r. 2 pi r is the circumference of a circle. H is the other dimension, and of course, the area of a rectangle is just length times width, right? So this is the length, this is the width, right? And then why 2 pi r squared? Well, we know that pi r squared is the area of a circle, right? And there's two of them. There's one on top and there's one on bottom. So the 2 is because it's top and bottom, and the pi r squared is because it's a circle, right? And I don't talk about that just to waste my breath, although I, waste breath for a lot of worse reasons in the run of the day. But I say that because it's important to know what these stand for in order to answer this exact question and a bunch of other ones like it, right? Because we look over on the side there and it says, well, draw a sketch of the cylinder. Oh, okay, not that part. Tennis balls are sold in cylinders with a plastic lid, and we want to find the surface area without the lid. So if we're getting rid of one of the lid, we're getting rid of one of the sides. So here, for our surface area, we're just going to have pi r squared plus 2 pi r h. We're going to get rid of this 2 because we're getting rid of the top. So now we can just go ahead and plug everything in like it's supposed to be. Pi times 4.2, because 4.2 is the radius of 8.4 is the diameter, right? Plus 2 times pi times 4.2 times 26. Now we just go through and crunch those numbers. 4.2 squared times pi. Again, I'm going to do them as decimals, like to 2 decimal places. 55.42 plus 2 pi times 4.2 times 26. 686.12. I'm going to add those together. 741.54 centimeters squared. As of course it's square centimeters because it's a measure of area. So that is all we had to do for that question. We've drawn a diagram, we've come up with our right answer, right? And we had a wonderful little trip down through a Mitch Hedberg bit, which is good. I mean, he only had like what 3 albums. It's really tragic. That was a real tragedy for stand-up comedy, let me tell you. But you know, from the years when I was really super into comedy, as opposed to now where I'm just kind of like passively into it. But from those years, I think I probably still have the entirety of all those 3 Mitch Hedberg albums memorized. I mean, at any given point, I probably could go into a 20-minute, list of just running through his bits. It's good stuff, though. So number 10, refrigerator is in the shape of a rectangular prism and needs to be painted. Refrigerator has a length of 24, 20, height of blah, blah, blah. Calculate the surface area of the sides that needs to be painted. Boy, hiccups again. This happens every day. I'm going to cover over that mug because it's branded with a company that I don't necessarily want to support on my stream. Not that anyone's going to see my stream and be like, boy, I want to go buy some Timmy's now. But come on. Tim's is like, they're still trying to milk the Canadiana for all it's worth, even though years ago they were bought by a Brazilian investment firm. And like they got rid of their original coffee supplier and got a different one. And like they've been cheaping out, and like the donuts are worse. And they're just like bringing in like dozens and dozens of different like random ass things that are none of them are very good. I don't know. It's pretty in vogue now to dislike Tim Hortons, but I got to tell you, it's correct. Tim Hortons is it's fallen far. But the main thing that does get me is the continual attempts to invoke Canadiana to sell coffee and donuts. Now that it's owned by a Brazilian investment corporation and all that, right? Like nothing against Brazil. I'm sure it's wonderful. And I would, like to go at some point. Just you don't get to call it, Canada's coffee shop when it's, funneling profits into a different country. Anyway. Okay. So this is 20 inches there, 24 inches there, and then how high was it? 45. 45 inches there. Now, the thing is, as we see this shape, right, it's a refrigerator. So part of the difficulty of this question is knowing what parts of the formula to use and what not to use, just like in part 9, right? So this is the surface area of a rectangular prism like so is going to be 2 length times width plus 2 length times height plus 2 width times height. Right? And we know it has to be those because, say, length times width is going to be the top and the bottom, right? Because there's 2 sides that have dimensions length times width. There are 2 sides that have dimensions width times height. There's the right side and the left side. And there's 2 that have width times height, which are the front and the back, right? But we know for a question like this that we don't actually have to paint the bottom and we don't have to paint the back. So we're going to modify our formula here, right? So if we don't have to paint the bottom, well, now we're only going to have 1 length times width, right? Because we're just doing the top. And I guess perhaps sometimes you wouldn't paint the top either, but let's assume that people are tall enough to see the top of the fridge. So we're going to paint the top. And then length times height, well, those are left and right, so we're going to keep on with those 2. Then we're going to have 1 width times height, because we're not going to do the back. Right? And this is sort of the difficulty of these types of questions, right? Surface area Now, let's go through and do those ones. Just fill in these guys. 20 times 24 plus 2 times, which one was I calling the length? Yeah, the length was 24. 2 times 24 times 45. Well, of course, that needs to be the one that's doubled because there's still the left and the right side. And then there's going to be 1 of the width times the height. So the 20 times 45. Right? And like I said a bunch of times, the difficulty of these questions is figuring out which of the sides you're left with and which ones you're not. 20 times 24, 480, plus 2 times 24 times 45, 2160, plus 20 times 45, 900. 900 plus 2160 plus 480, 3540. 3540 square inches. There we go. All right. I'm not going to go ahead and do the rest of those because I think the rest of the parts of question 10 are fairly straightforward. Right? But here for this one, we had to know that we don't paint the bottom or the back. Now, for my money, if I'm looking at a question like this, if this question was on a test, I would insist that the question sort of tell you that you're not going to paint the back or the bottom. You know, this is not a test of if people understand how fridges are made, right? Like maybe someone thinks maybe it's a flat back fridge. Maybe it's one of those ones that doesn't have like all the pipes and crap sticking out the back of it. Maybe you would paint the back, right? The answer key tells us that we don't paint the back. And I would agree that you wouldn't paint the back of a fridge because for a lot of fridges, like I say, it's all these pipes and coolant bits and stuff sticking off it everywhere. But if this was a test question that you were really going to be penalized for these ones, I would definitely include a part telling you which of the faces to paint and which ones not to. But either way, the important part of any question like this is figuring out which faces we're going to be counting and which ones we're not. Okay, back over to my intro here. Actually, let's go over to this intro again, just to take another brief look at it. It's quite nice and scenic, right? It's good. It's good. I think this is the island Normalm, I believe. I think this one is from Normalm, which is one of the ones in there. Which this is going to be a real nerd bit for a second. Like the entire stream isn't. But one of the blurbs that would pop up when you started Minecraft says like from the streets of Normalm. I'm pretty sure, right? Which is because this is the island where the island of Stockholm, because Stockholm's an archipelago. It's the island where Mojang has their studio, right? That's a game I feel a real hipster about, Minecraft, because I started playing Minecraft when it was in beta. I paid like €10 for it, right? Because it was just some random Swedish company that nobody knew anything about, and it was this weird block building like Legos game with monsters that like stoner kids would build replicas of their house in, right? You know how it is. You know what the internet is about. Anyway, so properties of angles recap and sine and cosine laws. Okay, so we're finally on to those. So that's Math 2101A stuff. Betty Ann, I know I've been yammering for a while now. We're at an hour and 10 minutes of yammering, but I'm finally getting on to the stuff that you had there. So hopefully you'll see it live, and if not, you're going to get it in the link anyway. But I'm going to pop back over here now. So now I'm going to start in on. I'm going to do question 9 here on this page. And this is a bit of a unit 2. Now, because this is one of the academic math courses, so for these courses, it's a bit more important to do to recap questions that you've already done, right? Because there is a final in these ones, right? So you will see this material again. Okay. So for question 9, what is the value of x? That's a bit tough to see, isn't it? Boy, oh boy, they didn't make that easy to look at. Let me zoom in. Okay, now we got it. We got it there. So we can see those two angles on the screen there. But what do we know about those two angles? Well, we know that when we add together, you're here? All right, great. Thanks for sounding off. All right, I'll carry on with these ones then. Drop a message in chat if there's any ones that you want me to spend more time on or anything specific you want me to go over. We know here that these two angles would add together to make 180, right? Because they're complementary with an E. Complementary angles with an I are angles that say nice things to each other. Like, Ma, you're looking very acute today, right? Right? That's good. It's a good. It's terrible. It's not good. Not good in any stretch. Anyway, my puns are great. All right, this is A plus material. I could go on the road with this if I ever stopped teaching. Right? Some math puns. So we know that those two added together make 180. So 8x plus 12x is 20x. Negative 10 plus negative 10 is negative 20. 20x minus 20 equals 180. Right? So then 20x equals 200. X equals 10. Right? It's fairly straightforward. For this next one, I wanted to do number 10 as well. What justification could be used to prove the following triangles are congruent? So what justification can we use here for this one? Well, the easiest justification to pick, like by far, well, we'll see the ones that we've got over here. And can we use any of these, right? Angle, side, angle. Do we have angle, side, angle? Now, you might be forgiven for thinking that we do have angle, side, angle, right? Because we know this side is the same as this side, and we know this side here is the same because it's shared, right? So then is this side the same as this one? Well, once we know that two sides of a triangle are equal, we actually kind of know that all three sides of a triangle are equal, right? So this is actually a kind of an odd question, because if two triangles have two sides that are the same, well, then the third side's got to be the same, especially if this is a right triangle. We know from Pythagoras that this is going to be equal to this. We can figure out their ones very easily. So honestly, this question realistically kind of should have been left off because any of these can be answers, right? Side, side, side. Well, you could get side, side, side. Yeah, of course you can. Because if this side is equal and this side is equal, then this one got to be equal too, right? The angle is the same and the side's the same. But from the way it's written, the most correct question, which is if you were to do like an SAT or a you know another bar exam or something like that, some real serious test, right? It always says the most correct answer, and the most correct answer here is the one that we can just read off the page here, which is side, angle, side, like so. So the answer they're looking for is option C, which is side, angle, side. But realistically, I don't like this question a ton because either of those four could honestly be said for this triangle. Because since we know this side and this side are exactly the same, worked it out right and wrote the wrong letter for 9. Oh, yeah, it's brutal. It's too bad. And that's the thing, right? That's the thing. One of the reasons I don't like multiple choice questions in general, because if it was a long answer question and I saw that you worked it out correctly and just accidentally wrote down the wrong number for your last step, you'd get like 2.5 out of 3 or 3.5 out of 4 or whatever. But for a multiple choice question, you do it all right and then you just circle the wrong answer and it's a big fat 0. So that's how that one works. Let me see. What else did I want to do on this one? Number 13. Yes. Question 13. Determine the value of the indicated variable in the diagram and the measure of angle A. So here we go. I'll leave it up on this scene because that's a fairly good size to use for that one. I'm going to try to be sparing with how much I use this green pen because it's the only green pen that I have right now until I make a sojourn to Dollarama and see if they've got any more. Maybe I could order some from Walmart, someplace like that. Order them from Amazon. Get them in, 3 or 4 weeks. Newfoundland does not get the fastest delivery from Amazon, I'll tell you that much. Two x plus 30, x plus 21. Okay, so now we have to determine the value of the indicated variables. Well, how are we going to go about determining these ones? Well, C, I don't necessarily think that C, or was C one of the ones we had to figure out? Yes, we had to figure out Y, X, Y, and C. Well, figuring out Y is fairly easy, right? Because we know that this plus this, let me do that in a different color. We know that this arc here, right, that I've done in blue, that represents a 180-degree line, doesn't it? So we know that 2y plus 54 has to equal 180, which means now we know that 2y is going to equal 126. We know that y then is going to equal 63. So it really doesn't look like it from the indicated angle there. It doesn't look like this is 126 and this is 54, does it? But, you know, it's how she goes, right? Like I say, the diagrams aren't drawn to look accurate. Now, for here, we know that because these two are across from each other, right? So this one is across from this one, like so. So we know now that C is going to equal 2y, which means C is going to equal 126, right? Because C is the same as 2y because it's right across from it. The other one that we need to know, right, is that these are opposite angles. This is a 54 here, and opposite, there's another angle in here, which is another 54 degrees, right? Because those are opposite angles. And we know that all three angles in a triangle add to 180. So now we know that 2x plus 30 plus x plus 21, I'll put those in brackets to show that they were sets, plus 54 has to equal 180 degrees, right? So if we put all this stuff together and simplify as much as we can, we're going to have 3x, that's 51, and then 54 is 105. 3x plus 105 is equal to 180. So then 3x is going to equal 75, and x is going to equal 25 degrees. Oh, I've scrolled off my page. So there we go. X is equal to 25. Okay. I think that was all that I wanted to get to on that activity. Yes, yes, it was. So now I'm going to go my final activity for today. Okay, we're going to come in. We're going to come in roughly on time, aren't we? We're going to come in roughly on time. I'm going to go on now to sine and cosine law word problems. So, Betty Ann, you asked for these ones just shortly before the stream began, I believe. So this is going to be, so the unit 2 is over this way. Oh, yep, we're on the wrong display. Unit 2 is over that way. So this is going to be Math 2101A Unit 3. So the Unit 3 is going to be down here below. All right, so then this is going to be question 4. It says a radio tower supported by 2 wires on opposite sides. One wire makes a 52-degree angle with the ground and is 20 meters in length. The other wire makes a 74-degree angle with the ground. Determine the distance between the wires. Hint, draw a diagram. Okay, so I'll take that hint and I'll draw myself a diagram. So this is the radio tower. So how am I going to indicate a radio tower? Whatever. Number 5. Yes, I believe you asked about 4 and 5, right? Or just number 5? Either way, that'll be the top of my... I'll get to both these. That'll be the top of my radio tower there. And we've got these 2 guy wires coming down like so. One wire makes a 52-degree angle with the ground. 52-degree angle with the ground and is 20 meters. And the other makes a 74-degree angle with the ground. 74 degrees. Determine the distance between the wires. So we're gonna need this distance across here. So we just need the distance across the bottom. So it looks like we have 2 triangles here, and indeed we do, but we also have 1 triangle, right? So if we were dealing with beforehand, where we only had the Pythagorean theorem as our tools, then we would need to sort of find this one and find this one, and then use this one and this to find this one, right? We would have a lot more steps to go if we just had our normal trigonometry and Pythagoras as tools. But because we have sine law and cosine law, hey, now all of a sudden we can get it much more easily. Because we can treat this as one big triangle, right? And if this is one big triangle, well, what's this blue angle? What's this angle up here? right? So I'll call this theta, right? So theta is going to equal 180 minus 52 and minus 74, right? Because it's one big triangle. So theta is going to equal, I'm not going to do that one in my head because I'm too lazy right now, 54 degrees. Okay. So this now is 54 degrees up here. Now that we have this, we can go ahead and do our sine law, right? So that's going to be A over sine A equals B over sine B, like so, right? And we have a pair, right, because we have this one and this one. So we know that 20 over sine 74 is going to be the same as this unknown side, the base over sine of 54. Right? Because we treat this as now one big triangle where the 20 is opposite the 74, and then this side, unknown side, is opposite the 54. And now we can go through and figure it out. So we're going to have 20 sine 54 divided by sine 74 equals B. So then we're going to have 20 times sine of 54 divided by sine of 74. 16.8. Yes. Good job. Well done. 16.8 is the answer there for number 4. All right, great. Okay. So then we've got this one more question down here that we want to get to. In a parallelogram, two adjacent sides measure 8.4 and 7.2. The shorter diagonal is 10.5. Determine to the nearest degree the measure of the larger angle in the parallelogram. All right, so let's splurge here and use another sheet of paper. I do use the opposite sides of these sheets of paper eventually for like writing notes and stuff on. You should see the stack of paper. Oh my lord. The stack of paper that I got since distance teaching started. Boy, oh boy. So this is math 2101A. Now this is still unit 3. And then we're going to do question 5. Okay. So in a parallelogram, so the thing about a parallelogram is we know that this side and this side are parallel, as are this side and this side. Okay, not the greatest diagram of a parallelogram, but we make do. Right? So two adjacent sides measure, I'll call this one 7.2 centimeters and this one 8.4 centimeters. Right? The shorter diagonal is 10.5. Right, so the shorter diagonal is going to be this one across here. Oh, let's do it a bit more accurately. There we go. So this is going to be 10.5 centimeters, right? So then, determine to the nearest degree the measure of the larger angle in the parallelogram. Okay. So the larger angle in the parallel, so this one's a bit of an odd question, right? But we know that the larger angle in the parallelogram is going to be this full angle across here, that full one there, right? So we're going to have to, boy, there's quite a few steps to go in this guy. We know that this one is 8.4 centimeters here, and this is 7.2, and this is 10.5. So what we can figure out first, say we can figure out this sort of red arc here, right? So what we're going to need to do basically is we're going to need to do the cosine law twice to get this one. And we know that, so we're looking for an angle here. So we know that cos of angle C is going to be a squared plus b squared minus c squared divided by 2ab, right? Because this is sort of a rearranged version of our cosine law. So here I'm trying to find this, this red arc here right now. So the cosine of this red arc is going to be, well, we know that side A can be our 8.4 and our side B can be our 10.5. But then our side C needs to be the one that's opposite the angle that we're looking for. So that one's going to be our 7.2. And that's going to be divided by 2 times 8.4 times 10.5. Then cos of C, right? So these questions do have a little bit of number crunching involved, as you're seeing. 8.4 squared plus 10.5 squared, subtract 7.2 squared, and 28.97, divided by 2 times 8.4 times 10.5, 176.4. So then C is going to equal the inverse cosine of whatever that is, 128.97, divided by the previous answer. It's going to get me, so it's negative cosine of 0.7311, inverse cosine of the answer. C is equal to 43 degrees, thereabout. So we know that a red angle up here is 43 degrees. And let's find this bit. Let's find this blue angle. How are we going to find that one? Right? Well, again, we know that if this is 8.4, then this is 8.4. If this is 7.2, then this is 7.2 over here. Right? So now we can go through and do our cosine law again for the blue one. Just it's going to be arranged slightly differently. Right? So again, we're going to have cos C equals a squared plus b squared minus c squared over 2ab. But now our cos C is going to be opposite the 8.4 now all of a sudden. So we're going to have 7.2 squared plus 10.5 squared minus 8.4 squared divided by 2 times 7.2 times 10.5. Like so on, right? So now we can go ahead and do this one. 91.53. $151.2. So C is going to be equal to the inverse cosine of 91.53 divided by the last answer that I got, which is going to be inverse cosine of 0.6054. So inverse cosine of the last answer that I got is going to be 52, or so we'll call that 53. C is equal to about 53 degrees. Right? So we can say, therefore, the largest angle in the parallelogram is 43 plus 53, which equals 96 degrees. There we go. All right, so we got there in the end. We know that a parallelogram is, of course, a four-sided figure, so its total angles are going to add to 180. So now that we know this is 96, we know now that this is 96. We know that there's 192 between those two, so the remaining, whatever, the remaining angles will be split between these ones over here, right? So we'd end up with, what, an 84 for both those. But either way, I know that there was a fair bit of splitting apart the geometry here. It does require, it does definitely require a diagram for this one, because the way it's written out is definitely difficult to get without doing that. But either way, that is, yeah, I think that should cover it. Betty Ann, yeah, let me know if there was anything else you wanted me to touch on for that one. But I think we've pretty much reached the end of our material for today that I needed to get to. Right? Thanks everyone for being here. I'm going to go eat this cookie that's been sitting here since I started. Boy, that's good. Oh boy. And to pause the mute the stream for a second so you didn't hear me chomping away at this, but it's a good cookie. All right. Yes, you're very welcome. Hope hope the math is going well. Hope everyone's staying safe and staying somewhat interested. Being productive and getting stuff done. I'm glad to be here helping people stay productive during these trying times. But yeah, we're making the best of it. Hopefully, keep getting through some courses, getting programs done. Stay safe, and yeah, I'll see you again tomorrow.